Now in problem number 9, we're given 4 different expressions, and we want to evaluate them when x is 5. So what we're trying to do here is this. If you take 5 and put it into this expression here and process it, what do you get back out? So put in a 5, process it, what do you get out? So input a 5, output what? Put the 5 down here in B. Put a 5 in here, process it according to these instructions, and then what do you get back out? That's the idea for all 4 of these. Now in part A, we're going to process the 5, right? Because up here they're telling us use 5. We're going to process the 5 using this set of instructions. So you put in a 5, that's your input, process it according to this set of instructions, and then what do you get back out? That's what we're trying to determine. So let's put a 5 in place of each one of those x's. So we're going to get 5 squared plus 6, I'll put a dot here, 6 times 5 plus 9. Now, order of operations. What do you do first, right? I'll put it up here. Powers and roots. We don't have any roots, but we have a power, right? 5 squared. And then multiply and divide, and then add and subtract. All right, so powers first. So let's take care of this 5 squared. So we're going to get 25 plus 6 times 5 plus 9. Now, maybe you can see you can do a couple of these at the same time. If you like, I could have done the 6 times 5. But one step at a time here. So 25. Now, let's go back. In this expression, running left and right, what do? We have a multiplication. So I'll do the multiplication first. So I'm going to get 30 plus 9. Okay, don't do this. Don't do 25 plus 6, getting 31, and then multiply that by 5. That's not what it says to do. Multiply 6 and 5 first, then add that to 25. Now all we have are 2 additions. So let's take care of this one first here. The 25 and the 30 is the 55, and then we have the plus 9. All right, adding those together, we get 64. So let's put a 64 into our solution box up here, or our evaluation box. Now for part B, we have this expression, x plus 3, and we're going to square it. So let x equals 5. So when x equals 5, right, put the 5 back right in here for x, we will get 5 plus 3 squared. Working in the parentheses first, we'll get an 8 squared, and that will give us 64. All right, so the answer to the second part here, let's put it in our solution field here, 64. Oh, so let's just look at both A and B now. In part A, we got 64, and in part B, we got 64. All right, so look at these expressions. In part A, it's x squared plus 6x plus 9. That produces 64. And in this case, x plus 3 squared produced 64. So you might think that this expression here is the same as this one, just maybe it looks different. All right, here's what I'm saying. I'll write it down. So we're wondering, does this expression here, does that expression at the top, x squared plus 6x plus 9, always produce the same output as the expression x plus 3 squared? Right, this set of computing instructions, is it the same as this one, just written differently? Well, we don't know that yet. Turns out it is, but we just don't know that yet, but we will produce that. We'll actually prove that they're equivalent. But right now, let's finish the problem. Let's move on to part C. Here's our set of computing instructions, x squared plus 3, and again, put in a 5, and let's see what this produces. All right, so here's our instructions. It says to whatever comes in, you're going to square it, then you're going to add 3. Now what's coming in is a 5. So let's take that 5, put it in place of the x, so we'll get 5 squared plus 3. All right, 2 operations here. There's exponential, or raising to a power, the 5 squared, and then the addition. Let's do the power first. So we'll get 25, and then plus 3. This will give us 28. So let's put a 28. Oh, I've already got it there in the field. And one more set of computing instructions, x squared minus 9. So whatever number comes in, call it x. Whatever number comes in, what are we going to do with it? We're going to square it, and then we're going to subtract 9. Now we're putting in 5, right? That's what the directions say to do. So when x is equal to 5, so put a 5 in place of the x, and we'll get 5 squared minus 9. Do the exponential first. 25 minus 9, that gives us 16. So now we will put a 16 back over here on the left into the part D. Let's get the red into our solution field. That's it. That's problem number 9.